Hello everyone again. Another important concept in Module 2 is hydrostatic pressure. So let's assume that there is a pool on backyard, right? And it's full of water, right? Uh, Now, at the surface of that pool, right? So if you have a pool, let me see if I can draw something like that for you guys. So let's say this is a pool, right? And then you fill it with water, right? Maybe up to this point, and make it blue, right? This is the surface of the water, right? What is the pressure at the surface of this water? Atmospheric, right? So at the surface, it's 1 atmosphere pressure. So here is 1 atmosphere, or 14.7 psi, right? Now, what happens as you go deep here? What happens to the pressure? The pressure increases, right? You have felt that, right? This is another picture of the same concept, right? As you go down, the pressure increases all the way up until you get to the end of that pool, right? To the very bottom of the pool. So this 1 atmosphere is called atmospheric pressure or air pressure, okay? And the way that this pressure increases depends on the density of the fluid, which is called basically pressure gradient of that fluid, okay? So for example, water have a different gradient, oil have a different gradient, right? So for example, water gradient is 0.433 psi per foot. Psi is pound per square inch. That's the unit of pressure petroleum engineers use, okay? So 0.433 psi per feet, okay? And it means that every 1 feet that you go down from the surface, the pressure increases by 0.433. Now, if you go 10 feet, what would be the pressure at the bottom? Think about it. 10 feet, right? So 10 feet, you just multiplied by the pressure gradient, which is 4.433, right? Which makes it 4.33 psi. Is that the pressure at the bottom? No, because you didn't consider the air pressure, right? The air pressure is 14.7 psi or 1 atmosphere. So you have to add 4.33 to the 14.7 psi, which makes the pressure at the bottom for our example to be equal to, I can write it here for you guys. So 14.7 psi, which is the atmospheric pressure, plus 10 feet multiplied by 0.433, right? Psi per feet, right? And what is the unit of 10? 10 feet, right? So you can see that this feet by this feet cancels out and the unit remains to be psi, right? So that makes it 14.7 plus, I guess this is not correct, right? 33. So 14.7 plus 4.33, right? So that's equal to whatever number it is, would be the pressure at the bottom of this. Now, this is the water gradient. Usually we have inside the reservoirs. If you have pure water, this is the gradient. If you have a saline water, which basically is a brine, a mixture of salt and water, the density is higher. It may go all the way to 0.465. The oil gradient, density of the oil is smaller, so therefore the gradient of the oil is smaller, which is 0.35. Now, how do you convert really the density into this gradient? So what you can do here is to let me write an equation here for you guys. This is an important equation in petroleum engineering. So pressure is rho gh, right? when you use the field units, which is the petroleum units that we use, it's going to be 0.052 multiplied by density multiplied by depth. Where did G go? Because we are using English field units, so that's gone already. We already put that number in. So what is the unit of density in this equation? The unit of density in this equation is pound per gallon. Okay. The unit of pressure is PSI, and the unit of depth is feet. Okay. So you can use this equation to find the gradient, right? But the gradient unit is what? PSI per foot, right? So P, since this is PSI per depth, which is feet, right, is equal to 0.052 multiplied by density, and density should be pound lb per gallon. Gallon is volume. Density is mass per volume, right? So pound mass per gallon. So if you have your density in pound per gallon and you multiply it by 0.052, you get the PSI per feet. Now for water, the density of the pure water is usually 8.33. So I can calculate the gradient. So gradient, which is pressure divided by depth, is equal to 0.052 multiplied by 8.33 pound per gallon. It's simple to convert your density. You know the water, you know that it's 1000 kilogram per cubic meter or 1 gram per cc, but you can convert it to the field units, which is pound per gallon. That makes it to be 8.33. So if you multiply these numbers, which are 0.052 multiplied by 8.33, that makes it 0.433 psi per feet. So if you have the density, what you need to do is just to convert it into pound per gallon. Once you convert it into pound per gallon, it's simple to just put it into this equation, get the gradient out. Okay, so that's it for this video. We'll continue on the topic.